Hello everyone. In today's lesson we're going to be learning how to add and multiply surds. I'm going to begin by thinking about squaring a surd. So let's say I've got root 6 squared. Think about what squaring a number actually means. So if I've got root 6 squared, I'll be multiplying it by itself, right? So I've got root 6 times by root 6. I've written it out longhand. Right, well, we know when you multiply two surds together, so for example, root 6 multiplied by root 6, that will give me root 36. So I just times them together like normal numbers. But the square root of 36 is 6. So I want you to think, what do you notice? What's interesting about that question? So if I've got root 6 squared, that just gives me normal 6. And when you think about it, if you're taking a 6 and you're square rooting it, but then you're squaring it, you're doing the opposites. So you're rooting it and then you're undoing that root by squaring it. So we can generalize. We can say if you square root a number and then square it, you just have that number that you started off with. So root 6 squared is normal 6, and that works for any integer in this form. Okay, so let's think about another question. What happens if I've got two lots of root 6 squared? Well, writing out longhand, that just means two lots of root 6 times root 6. But we know root 6 times root 6 is just normal 6. So we know that when we square a surd, you just get that normal number inside it. So 2 times by 6 is 12, and that would be my final answer. So notice I've just taken my answer from before, so root 6 squared, and I've times it by 2 because I've got two lots of root 6 squared. And 2 lots of 6 is 12. Alright, so see if you can predict what I'm about to do for this last one then. So I've got two lots of root 6 cubed. So what's the first thing I'm going to do? So I'm going to write it out longhand. So I've got two lots of root 6 times by root 6 times by root 6. Alright, so how can I tidy this up a little bit? So could I take what we discussed with that first question to this question as well? Well, yes, I can. Let's focus on these middle two terms. So I've got root 6 times by root 6. We know that root 6 times by root 6 is just normal 6, isn't it? So I'm just going to update. I'm going to tidy this up. I'm going to call this two lots of normal 6 times by root 6 at the end. Two lots of 6 is 12. So I'm going to call this 12 root 6. All right? Okay, so I've done the first one for you for this one. In your best books, please can you write the title adding and multiplying surds, and then in your best books can you have a go at these examples on the right hand side of your screen, please. So pause the video, take some moments to try these questions. Alright then, so our first one, so I've already done that one for you. So root 7 squared, we know that when you square a surd, you just get that normal number inside of it. So root 7 squared is just 7. So let's think about what two lots of root 7 squared looks like. So that would be two lots of root 7 times by root 7. And we know that when we're squaring a surd, we just get that normal version of the number. So I've got two lots of 7, which is 14. For this last one, if I write it out longhand, first of all, I've got two lots of root 7 times by root 7. And taking these middle two numbers, so root 7 times root 7, I know it's just normal 7. So it's two lots of normal 7 multiplied by root 7, which is 14 lots of root 7. Okay, so I'd like you to work through this sequence of questions, please. You can use your rough books for this, so you need to pause the video now, and once you're ready, you can unpause the video for your solutions. Okay, so here are your solutions to that task, and let's move on. Okay, so let's think about what happens when we multiply two different surds then. So root 15 multiplied by root 5, so this is my first example. I can't really simplify either of these surds as they are, so what I'm going to do, I'm going to just times them together. So root 15 times by root 5 gives me root 45. I know that because factors can be written as one surd as well, so it's root 45. So if I'm asked to simplify this, so if I'm asked to simplify root 15 times by root 5, I'm going to piece it together, and then I'm going to simplify this one third. Remember, when we're simplifying a third, we're looking for factors which are a square number. Right, so what's the largest square number factor of 45? Well, I know that 9 goes into 45. Therefore, 9 times by 5 can be simplified to 3 root 5, because the square root of 9 is 3. Alright, so just as you did before, please can you pause the video at this stage and have a go at this example in your best books. Alright, so the first thing we're going to do to simplify this expression is, well, we're going to combine it. So we've got 6, root 6 times by root 8 is root 48. So I can times surds together just like I times together normal numbers. So now I'm thinking to myself, do I have any factors of 48 which are a square number? And specifically, I'm looking for the largest square number, and that will give me my simplest form. So the largest square number that goes into 48 is 16. Root 16 multiplied by root 3 gives me 4 root 3. I know that because the square root of 16 is 4. Okay, so I would now like you to work through this sequence of questions. You can do this in your rough books. So just like before, this should take you around 10 minutes or so. So pause the video, and when you're ready for the solutions, please unpause the video. Alright, so these are your solutions to that task. So pause the video if you need to, but we're going to move on now. Alright, so we're going to move on to adding surds. So I'm going to give you some very, very basic examples first of all, and then we're going to build up to how we add surds together. So first of all, 2 apples plus 3 apples. Obviously we know that would be 5 apples, wouldn't it? But let's think about when we add together lots of things. So let's say I've got 2 lots of 10 plus 3 lots of 10. Okay, right, the answer to this is 50, but I could also write this as 5 lots of 10, couldn't I? Let's say I had 2 lots of x plus 3 lots of x. When I add together lots of x's, I get 5 lots of x's. So I'm adding together these two initial numbers. Alright, so 2x plus 3x would give me 5x. So hopefully we're getting the idea. Surds are absolutely no different to anything that we've counted in our life. So we've counted apples, we've counted numbers, we've counted algebraic expressions. When you count surds, you count them in exactly the same way as you've always done. So if I've got 2 lots of root 5 and I'm adding on 3 lots of root 5, altogether I have 5 lots of root 5. Okay, so what we do, you just add together those numbers in front of the surds, because you're effectively just counting how many of that surd that you have. Alright, so let me show you exactly what this would look like, say, in an exam. So if I'm asked to add together these two terms and simplify, if I've got 2 lots of root 5 and I add on 5 lots of root 5, altogether I have 7 lots of root 5. It just kind of makes sense when you say it out loud. 2 lots of root 5 plus 5 lots of root 5 is 7 lots of root 5. So when you're adding together the same surd, you can kind of treat it like an x, like you do in algebra. 2 lots of root 20 plus 5 lots of root 5. At the moment, my surds are different. I have a root 20 and I have a root 5. When you're adding together pieces of algebra, so algebraic expressions, you know when you're collecting like terms, so you wouldn't add together x's and y's, would you? Yeah, you'd treat them separately. So here, I can't add them together yet because a root 20 is different to a root 5. However, I can simplify 2 root 20. When I simplify 2 root 20, I get 4 root 5. Okay, because I split 20 up into its factors of root 4 times by root 5. The square root of 4 is 2, and 2 times 2 is 4. Alright, now that I've simplified that first surd, do we see why that was helpful? Now I have 4 root 5 plus 5 root 5, so altogether I have 9 root 5s. So I simplify to ensure that these two roots are the same. I can only add them when my surd parts are the same. In this third question, it's a little different. My surds are different, so root 20 is different to root 10 clearly. What I need to do, I need to fully simplify each surd. 2 root 20 I have already simplified, that gives me 4 root 5. I cannot simplify 5 root 10 any further. I know I can't simplify 5 root 10 because there are no square number factors which go into root 10. Because I can't simplify either of these surds any further, I can't really add them together as one term, so I leave my final answer like this. I know it looks a bit strange because you've got an add sign in your final answer, but this is as simple as I can make it because I can't simplify either term any further. So this is my final answer, 4 root 5 plus 5 root 10. Alright, please can you pause the video and try these 3 worked examples. So you can do these in your best books and unpause the video when you are ready to move on. Okay, so 2 root 6 plus 5 root 6 is 7 root 6. When I simplify my first surd, I would get 6 root 6. I can't simplify the other one any further. So here I've got 6 root 6 plus 5 root 6 gives me 11 root 6. The reason I can add them together is because both terms share a root 6, so I just count together how many root 6s I have. In this last question, I can simplify my first surd because 20 has a square number factor of 4, but I can't simplify the second surd. So what I do, I simplify this first term, and that second one just stays as it is, and that's my final answer. There's nothing else I can do because I can't simplify either surd any further, and I don't collect them up together because root 15 is different to a root 5. Alright, so please can you work your way through this sequence of questions. Just like before, you can use your rough books, please. So unpause the video whenever you are ready for your answers. Okay, and these are your solutions to this task. Okay, so if you're in class, I'm not sure if you're going to have time to get onto this, so don't worry if you don't. But if you need something else to do, here's a quick true or false activity. It's just based on the things that we've been learning together so far. So pause the video to work through these if you like, and unpause the video when you're ready. And if you finish absolutely everything, please feel free to grab a blue GCSE textbook from the back of the room and find some Sirds activities in there to be getting on with. So use your context. Use your contents page, and we are looking for Sirds in the book if you need some extension. All right. If you need any if you have any questions about anything we've learned today, please just let me know on Google Classroom, and I'll be more than happy to help you.